Let's get into it. You know, when you look up at a modern airplane, you're not just seeing this incredible piece of machinery. You are looking at one of the most complex electronic systems humans have ever built. So today, we're pulling back the curtain on the world of avionics, the literal brains of modern flight.
Seriously, today's aircraft are basically flying supercomputers. They are absolutely jam-packed with sophisticated electronics that control, well, everything. We're talking navigation, communication, and even the flight control systems that keep the plane stable and perfectly on course. It's this whole intricate web of hardware and software that guarantees everything is safe and precise at 40,000 feet. And that leads to a huge question, right? Because when you're up in the air, there is zero room for error. The answer? It's a very specialized group of pros. The people who design, build, and maintain these incredibly complex systems day in and day out.
Now, to really wrap your head around this field, you got to understand the two main roles that make it all happen: the avionics engineer and the avionics technician. They might sound kind of similar, but they handle totally different and equally critical parts of the whole process. So here's the easiest way to break it down. Think of the engineers as the architects. They're the ones designing and developing the systems from scratch. The technicians, well, they're the hands-on experts. They install, they troubleshoot, and they repair those systems to make sure they work perfectly out in the real world. One designs the brain, the other performs the surgery.
Let's zoom in on the engineer for a second. Their work happens way before a plane ever leaves the ground. They're designing circuits, writing the firmware for flight computers, and making sure dozens of different subsystems can all talk to each other flawlessly over these special networks, these data buses called ARINC and CAN. And it's their job to build in backups for the backups, so if one system fails, another one just takes over instantly.
And I love this quote because it perfectly captures the technician's world. These folks are on the front lines making sure that mission-critical gear works every single time. And focusing on cockpit displays, that means making absolutely sure the pilots have perfect, accurate info right in front of them. Engine status, fuel levels, you name it. It's a job where precision is absolutely everything.
So what does that work actually look like? This isn't just about swapping out a broken part for a new one. Oh no. It's a meticulous craft that mixes deep technical knowledge with this insane focus on safety and detail.
The whole repair process is super systematic. You have to be. First, a technician runs tests to find the exact problem. Then, they dive into the technical manuals to order the very specific, certified parts they need. Next comes the repair itself, which, you guessed it, requires incredible precision. And finally, and this is so important, they run a whole new set of tests to verify that the system is perfect and meets every single safety standard before it even thinks about going back into an aircraft.
Yeah, this image right here just says it all, doesn't it? It's this amazing blend of high-stakes technology and the kind of expert craftsmanship that's been part of aviation from the very beginning. Every single connection, every little component has to be flawless. In this job, there's just no other way. So what does it actually take to make it in a field like this? Well, it's a really unique combination of deep technical know-how and a very specific mindset. And for the people who have it, the rewards and the demand are pretty significant. On the technical side of things, an engineer's toolkit is, well, it's loaded. You're talking embedded software development in languages like C and C++, deep knowledge of those avionics data protocols, and model-based design with tools like MATLAB. It's a really challenging mix of hardware, software, and systems thinking all rolled into one. But honestly, the tech skills are only half the story. The mindset is just as important. We're talking about an extreme sense of responsibility, a rigorous attention to detail, and a real knack for practical troubleshooting. These things are totally non-negotiable. This is a field where you have to constantly be thinking about how one tiny part could affect the entire aircraft.
And a skill set that unique, it's highly valued. The median salary for an avionics engineer in the US is sitting around $122,000, and that number really reflects the deep expertise and, frankly, the immense responsibility that comes with designing systems that keep people safe.
And the demand for these skills is really steady. The whole field of aerospace engineering, which includes avionics, sees about 1,600 job openings each year in the US alone. So that tells you there's a consistent, healthy demand for this kind of talent.
Okay, so how do you get there? If any of this is sparking your interest, there's actually a really clear path to building a career in avionics, whether you see yourself as an engineer or a technician.
It all starts with a solid foundation, usually a bachelor's degree in electrical or aerospace engineering. From there, getting your hands dirty with real experience from internships or technician jobs is absolutely key. Then you build up a portfolio of projects and go after industry certifications, like for DO 178C. That's the global gold standard for aviation software. Do all that, and you're set up to advance and start leading the design of the next generation of flight systems.
And trust me, that future is going to be incredibly exciting. We are on the verge of a full-blown revolution in aviation. Flight is getting more autonomous, more electric, and more connected than we ever imagined. And that brings up one final, really important question for the next generation of innovators.
So where is all this headed? Get ready for this. We're talking about the avionics that will power urban air mobility. Yeah, flying taxis. We're talking about the advanced cybersecurity needed to protect planes from new kinds of threats. Engineers are going to be creating power systems for electric airplanes and the brains for hypersonic spaceplanes. The challenges are massive, for sure. But for those who are ready to build it, the future of flight is wide open.